In this video, we will discuss a second, potentially easier method to find the probability that you will win the jackpot. If all goes well, then we should get the same answer as the last video. First, let's recap some probability theory. Suppose we roll 2 dice and we want to find the probability of landing on a 5 on the first die and a 5 on the second. Note that the event where we land on a 5 on the first roll has no effect on the event that we land on a 5 on the second roll. Such events where one has no effect on the other are called independent events. So, the probability of landing on a 5 on the first roll and a 5 on the second roll is given by the conveniently named AND rule, which says that to find the probability of 2 independent events occurring, we just multiply the individual probabilities, which gives us an answer of a 1 in 36. Now, let's calculate the probability of landing on a 5 or a 6 in one roll of a die. Clearly, we can't land on both a 5 and a 6, so this is an example of what are called mutually exclusive events, events that cannot both happen at the same time. When this happens, the probability that either event will occur is given by the OR rule, which tells us to add the probabilities of each event. In this case, we get an answer of a third. Now that's out the way, let's get into the interesting stuff. There are 6 balls drawn from the lottery machine, so we will view this as 6 separate draws. Now let's assume that we win the jackpot and that we match all 6 draws. The first draw is randomly selected from 59 balls. If we had to guess one number between 1 and 59 to match this ball, we would have a 1 in 59 chance of doing so. But since we chose 6 numbers, each of these has probability of 1 in 59 in matching the ball chosen by the machine. So by the OR rule, we add all these probabilities up, giving us a probability of 6 in 59 that we match the first draw. Now for the second draw. The first ball is not replaced, so the lottery machine has 58 remaining balls. One of these 58 is randomly selected. Since one of our chosen numbers has already been matched to the first draw, we have 5 remaining numbers, each with a 1 in 58 chance of matching the ball chosen by the machine. Once again, using the OR rule, we add up these probabilities to give us a probability of 5 in 58 of matching the second draw. And so on. We do this for all 6 draws, which gives us the following probabilities for matching the 3rd, 4th, 5th and 6th draws. We can represent this in a tree diagram. It shows all the possible outcomes for each draw, i.e. a match or a no match. But we are only interested in matching each draw to win the jackpot. So we continue our tree diagram, inserting the probabilities we have just calculated for matching each draw, to match the first draw and the second draw and the third, and so on all the way to the 6th draw. This time by the AND rule, we take our probabilities of matching each draw and multiply them together, which tells us that we have approximately a 1 in 45 million chance of winning the jackpot, which is just as we expected. You might be worrying that the odds are against you, and you'd be correct. Let's put this into perspective. It's 4 times more likely to be hit by part of a plane falling from the sky than securing the jackpot. Something more interesting is the odds of being left-handed and using a right-handed product incorrectly and dying from doing so is 10 times more likely than winning the jackpot. If after this video you still want to try your chances, good luck!